Welcome to Digestion and Physiology, Series 2, Part 3, Non-Structural Carbohydrates. In the previous clip, we looked at structural carbohydrates as a nutrient component of a horse feed. The other main carbohydrate type is non-structural carbohydrates. Non-structural carbohydrates consist of sugars and starch. Let's start with sugars. There are many different types of sugars, such as sucrose, glucose, maltose, galactose, fructose, and many more. They are largely digested in the small intestine. It's important to note that structural carbohydrates are primarily digested through microbial fermentation in the hindgut in the large intestine, and that non-structural carbohydrates are mostly digested in the small intestine through enzymes produced within the body of the horse. These complex sugars are broken down into simple sugars which pass through the intestinal wall into the bloodstream and travel as glucose to the liver to either be used as an energy source or stored as fat. Some can be stored temporarily in the muscle as glycogen as an immediate energy source for the fight or flight response, or more beneficially, for the horse rider, galloping. Remember, energy is not lost, it is stored or used. The other main form of non-structural carbohydrates is starch. Starch is abundant in grain and grain-based feeds. Both sugars and starch are often found in high levels in grains. Starch is a type of sugar, but because of its chemical compound, it has 2 or 3 times as much resistance to digestion as other sugars. This increases the risk that less is digested in the small intestine, with a large proportion ending up in the hindgut. The problem with this is when you get large amounts of non-structural carbohydrates, particularly starch, in the hindgut, lactic acid is produced. Lactic acid lowers the pH of the hindgut region below the optimal range of between 6 and 6.7, causing the death of many of the microbes necessary to ferment the structural carbohydrates. These dying microbes release endotoxins, which can damage the intestinal wall lining, resulting in a sick horse potentially suffering from laminitis, colic, leaky gut syndrome, and more. It is very important to realize that high levels of starch can be detrimental to the health of the horse. To regulate the pH in the hindgut safely, it is important to include high concentrations of structural carbohydrates or fiber in the diet to support the fiber digesting microbes and minimize those that produce the lactic acid. Today, our key take-home points from this YouTube clip are: non-structural carbohydrates consist of sugars and starch. Sugars are largely digested in the small intestine through enzymatic activity. Starch is much more resistant to digestion as other sugars and poses the risk of ending up undigested in the hindgut. Non-structural carbohydrates, particularly starch, digested in the hindgut, produce lactic acid. Lactic acid in the hindgut can cause significant health issues for the horse, such as laminitis, colic, and leaky gut syndrome. It is important for gut health to include high levels of fiber in the diet. Thank you for watching Equine Digestion and Physiology Series 2, Part 3. If you like what you saw, please give us the thumbs up and share it with your friends. Connect to our website, our EqNC Facebook page, and Instagram so as not to miss the next chapter in this series.